Electronic scrap is the fastest growing waste stream in the world. Annually, more than 15 million metric tons of electronic waste are generated. So far, less than 20% are recycled. Because of its high content of valuable materials, electronic waste is a resource especially for all kinds of metals. The German-based company UMS provides urban mining solutions for commodity recovery from this resource. UMS technology is derived from proven ore mining technology. It follows the philosophy of the immediate takeout of each first separated fraction, no matter if valuable or not. Unlike other scrap processing technologies, the UMS way of processing doesn't start with a shredder, as shredding always compacts materials. The so-called ERP1 system starts with automatic dismantling by a rotor chain crusher. The input materials are opened instead of compacted when being hit by a set of heavy rotating chains. The appliances break into parts and major components are liberated. When leaving the rotor chain crusher, all dust, fluffy and light materials are sucked off by a powerful fan and separated in several stages. Liberating big ferrous components are taken out by a first overbelt magnet separator. In order to obtain a very clean ferrous metal fraction, any entrained impurities are sorted out manually. The non-ferrous fraction passes a rifle chute, securing the sorting belt not to be loaded with small parts. Trained personnel takes out marketable components, such as motors and transformers. They sort out stainless steel, aluminum, boards and valuable plastics, as well as copper wire and hazardous materials. All sorting residues, as well as the small parts, are screened out by passing an eddy current system to separate the non-ferrous from the ferrous fraction, ready to be processed in the ERP2 system. Following its philosophy derived from ore mining, UMS designed its ERP2 system as a set of independent subsystems. This ensures highest flexibility concerning the production of secondary raw materials. A down-to-size shredder ensures the homogenization of size, which is a prerequisite for some of the following processes. It can also be the final step for metal or plastic fractions already marketable. Small parts, including valuable metals, are fed to the UMS proprietary double rotor hammer mill. Here the compounds are delaminated and transformed in grain shape and size when hammers drive them through the mill. Some metals tend to form balls, other metals remain flat, while plastics always remain flat. This enables further separation. UMS uses various screening machines to classify materials by their size. As narrow spreads in size are preconditioned for maximum quality of further separation, screening is one of the key factors to match the criteria for end of waste. The application of UMS air jigs to properly screened mixed materials separates metals from plastics as well as aluminum from copper and copper alloys. Having passed this process, materials show purities of more than 98% and often match the criteria for direct use in processing industries without undergoing a melting and conditioning process. UMS applies HARMOS electrostatic separators for the separation of conductive from non-conductive materials of small grain size. Passing a corona field, all conductive materials are deflected and separated from plastics and fibers. Combining ERP1 and 2 systems guarantees maximum recovery of commodities from electronic waste. The German engineers at UMS have integrated ore mining experience with state-of-the-art systems engineering and serve its worldwide customers with real urban mining solutions.